Hi, my name's Tim. I'm from Carno, and I'm here to talk through our MVP, which is a sizing and design tool for heat pump installers. Um, so the goal of the tool is really to increase your efficiency from when you receive a new inquiry about a new project, allowing you to do a whole house calculation, and then the room by room heat loss, as well as heat pump selection, cylinder selection, and radiator optimization. So I'm going to go through and create a new project and add some details. Once I've completed entering the details, I'll hit save, and we can go on to the whole house calculations. We have two methods, one of which is using the total floor area and house build type. We also use a method which allows you to look at energy usage and average design temperature to work out the whole house calculation. It's up to you which one you use. Let's go with this for now. And hit save. I'm now going to pass on to Justin, who's going to take you through the room by room calculation on site as it would be done in real time.
I'm now at the property and can see the project Tim has created. On my phone, I can click on the project, see the details he has entered, and can now go ahead and start the room by room survey. Here, the first thing I do is I have to enter the heating zone. Then I can go back and start adding rooms. We can add the first room and enter all the room data. So we input the name, the year of construction, the type, which gives us the design temperature, the dimensions, and some other questions. So let's go ahead. So the name, Tim's living room, year of construction, type, gives us design temperature, average length, average width, average height, if there's an open fire present, temperature drop during setback, and the heating zone it is on. Then, once we've done that, we now have to add the elements. Let's start with the floor, where we enter the length, the width, the type, and then the U value. When we select the type, this will also determine what other questions we may be asked. For example, for the ground floor, the next question then is if the adjacent space is the ground or the outside, if it's a suspended floor. Now we have to do the ceiling. In the ceiling we can also add roof lights if that's necessary and enter the dimensions as well as the fabric type and U value. And then we also have to add walls, of course, where we now go ahead, enter the dimensions, the type, and then some other questions, and then the U value. If we enter external wall, we then can also enter if we've got windows or doors. So we've added the window now. We don't have any doors on this wall. Let's say this is an internal wall, and therefore we also have to select an adjacent room. So let's go ahead, add a room, and then we can make progress. Then we can also add radiators in the room. Here we have to enter the dimensions of the current radiator, as well as if there's space available for a new radiator. Once we've done all that, we then would go forward with the second room.
So Justin's taking me through the room by room examples, and now we've added a few additional rooms. So now I'm going to take you through system upgrades. So by setting the flow temperature in the heating zones to 55, there will be some calculations done to calculate the heat generated from the emitters within that space. And you can see in Tim's living room that number is particularly low. That's because we've got a small radiator in a large room. And we can actually go in and replace that. And we can see the available dimensions from the data inputs when we're doing the room by room. So let's go ahead and do that. You can see that the options available in the product catalog are selectable. You can see Myson radiators displayed there. Let's go ahead and check each of the other rooms. Okay, that's looking good. Let's move on to hot water demand. So we'll add the number of bedrooms, the number of occupants per bedroom, the hot water usage, the target cylinder storage temperature, the cylinder start temperature, and the frequency of the emergency heater usage, as well as the number of cylinder recoveries that we need. I'll do that now. This will calculate the hot water demand for the property, which will help us define the air source heat pump. As you can see, the heat pumps available, we're just adding these to the product catalogue now, so there will be many more as we do that. So I'm just going to select Mitsubishi for now. We'll then move on to cylinder selection, where again, we're just adding those products in. But we can look at the hot water or the usage per day of 180 litres. This one is the appropriate size. Now we can move on to noise calculations. And in alignment with MCS standards, we can select the various options here and hit save, and that will align with the requirements for MCS. And now coming to the end, we can generate a report for each of the items of the project, which will give you a summary to send over to your homeowner. Thanks very much for watching. Here's a quick preview of the report. We're still bringing some of this together, but it's all in alignment with MCS, showing you the space heating, radiator schedule, hot water cylinder, and then the room breakdown.